All right, so in section 11.4, we're going to be talking about two different types of probability. And one probability, it's something that's called the, can you guys say this word? Theoretical. I'm not good at pronouncing it. Theoretical probability. And the other one is empirical probability. So theoretical probability is something like tossing a die. For example, if I have this die, it's a funky looking one because it has 1, 3, 5, 7 on one side, and then it goes up to 8, 2, 4, 6, and 8. Okay? So it's not a regular die, it has 8 faces. What's the probability of rolling a 5? 1 out of 8, right? Ooh, did I get it? No. And then I could keep going, keep going. What's the probability of rolling an even number? 4 out of 8, which is 1/2, and that makes sense because half of this die is even and half of it is odd. Okay, so that's a special one. So you guys have seen problems like this. An occurrence for which the outcome is uncertain is called the experiment. Is anything uncertain here? No, we're going to get numbers. They're going to be 1 through 8. So this is not an experiment. This would be the theoretical probability, but we still call it an experiment because we don't know which number we're going to get. The set of all possible outcomes of an experiment is the sample space. So the sample space are all the 8 numbers that I've been talking about. An event is a number that I want. If I say, what's the probability of rolling a 5, that's my event, rolling a 5, and I could keep going until I get it. Theoretical probability applies to situations in which the sample space only contains equally likely outcomes. So that's this one, because they're all likely. It could land on any of the faces. To calculate the probability of an event, we divide the number of outcomes resulting in the event by the total. So how many faces did I have in this one? 8. How many numbers am I asking you about? Only one at a time. So here's the notation that we're going to use. P of E stands for probability of an event, and the event could be a number, or like the Kahoot that we played with the socks, or the birds, or the marbles. And basically when you think of it, it's like N of E, N of S. It's what you want, or what you're being asked about, over the total. You always divide by however many items you have. So what are the 2 different options you could get when you toss a coin? What are those? Heads or tails. If you toss a coin, it is equally likely to land either heads up or tails up. The actual outcome is unknown. Calculate the probability of a coin landing heads up. Well, how many heads do we have on a coin? 1. Only one side of a coin has heads, the other one is tails. And how many different possible outcomes do we have? 2. So that's why anytime you do a coin toss, it's 1/2. Because if you're being asked about an event, specifically this one is heads, and this one is the outcomes. And the outcomes are either heads or tails, so there's only 2. Theoretical probability applies to many games of chance, including dice rolling, lottery, card games, and roulette. So, Kevin, can you read example 1, rolling a dice? On your own paper.
When a die is rolled, there are 6 equally likely possible outcomes. The sample space can be shown as S equals 1, 2, 3, 4, 5, 6. If a die is rolled once, find the probability of rolling.
Okay, so what's our total? What's going to be the denominator for all of these fractions? 6. So what's the probability of rolling a 3? How many 3s do we have? There's only 1, so it's 1 out of 6. What about an even number? How many even numbers do we have? There's 3 even numbers, so it's 3 out of 6, which you always need to reduce, which is 1/2. What about a number less than 5? The number less than 5 is 4, 3, 2, 1. So there's 4 of them out of 6. When you reduce, it's 2 over 3. What about a number less than 10? Well, there's how many numbers are we having that are less than 10? 6. How many are we choosing out of? So it's 6 out of 6, which is 1. Whenever you get a probability of 1, it means that it's 100% probability. So if I say, oh, if I roll this die, am I going to get a number less than 1? How often? What's the probability? 100%, because all of them are going to be less than 10. That's what I meant. What about a number greater than 6? How many numbers greater than 6 do we have? 0. So 0 out of 6 is 0. Are we okay with this? All right, for the next thing, how many red cards do you have in a standard 52 card deck? How many? Red cards. Red, like the color red.
Like,
Not the symbols. Color. Red or black. How many cards are red? 26. How many are black? 26 as well. So there's 52 cards. Half of them are red, half of them are black. If you are a card player, maybe you guys can help me. Do you guys know what this is called? A club, right here. What about this one? Diamonds. What about this one? Hearts. Spades. So if you want to write that down, what was that again? Clubs, diamonds, hearts, and spades. Which ones are face cards? All the ones that have a face. What about aces? Do they count as face cards? I have to check that. I'm not sure.
I've never seen that before.
These, I don't know what that is. They're crossed off, so I don't know what that is. Yeah, those would be the extras. How many queens do we have? How many kings do we have?
4.
How many red... Kevin, move over. Move over, you're distracting me. Like every time, maybe it's relevant, but like sit there. Or Juliana, or someone from that group. Because you're talking.
well, I'm trying, you're asking a question.
Okay, how many red kings do we have?
I said a lot. I'm making like 4. I was trying to count.
No, I'm actually asking how many kings that are red do we have? I'm asking him. How many red kings do we have? 2, right? How many black queens do we have? 2, okay? So you guys can use this if you're not familiar with card playing. You can have this in front of you as we do card questions. So let's have you answer these. What is the probability of being dealt a certain card? So when you guys are writing this, a king, there is 4 of them. So when you're writing it, make sure you reduce. So it'd be 4 over 52. Figure out what that is. Why don't you guys do B, C, D, and E? Bless you. Where are the kings? Because it's asking about all kings. How many kings do you have? Where are kings? It's the one with the K? Yeah. You guys are doing all the way after E. Rachel, I'll ask you to read example 3. Do you want to read it to yourself first as practice? Well, I know. So on here are the red ones are diamonds and hearts. The ones in the middle.
Oh.
So I know this should be in color. Got it? Don't put your music in. You just got yelled at. And I'm sure you're just talking about something like fun and random, but multitasking.
What are you saying about this?
Oh,
I was answering the question.
okay. All right, Jacob, did you guys figure out B? What about for the hearts?
13 out of 52.
Which reduces to 1/4. Very good. 13. How many hearts do you have?
Oh, you have to include the faces too.
Everything. Everything that has a heart. There's 13. Okay. Lupe, what did you guys get for the red cards? 26 over 52. Because it's the hearts and the diamonds that are red. Brianna, what did you get for D? A black queen. What is it? It's actually 2, because for the queen, we have 4 queens. So the club and the spade, the top one and the bottom one, those are going to be black. Oh, were you? Never mind, 1 out of 26? Yes, my bad. I misheard you. Okay. And for the last one, Patrick, what did you get? 1 out of 52, because there's one pin like that. Okay? Next example, Rachel, could you read example 3 for me?
Each person carries 2 genes that are related to the absence or presence of the disease cystic fibrosis. Most Americans have 2 normal genes for this trait and are unaffected by cystic fibrosis. However, 1 in 25 Americans carries 1 normal gene and 1 defective gene. If we use C to represent a defective gene and C a normal gene, such a carrier can be designated as CC. Thus, CC is a person who neither carries nor has cystic fibrosis. CC is a carrier who is not actually sick, and CC is a person sick with the disease.
So this really is just like a very complicated way. Let's talk about, like, if you have a parent and a second parent that both carry the gene, so it's little c, and then for this one, the first parent has the little c and the capital C, so like the defective gene and the normal gene. What if you have the first parent has the normal gene, the second parent has the defective one, and finally normal and normal. So there are 4 different possible outcomes, okay, that could happen for a child. If 2 parents each carry one of the genes, what is the probability that their child will have cystic fibrosis? So what that is asking you, this is the one where they would be sick. So there's only 1 out of 4, so it's a 25% chance of that child having the disease. All right? All right, for the next part, I am going to ask that you guys find a coin, because you're going to be doing some coin tossing. The next empirical probability applies to situations in which we observe the frequency of an occurrence. Theoretical probability is what we were counting before, because in theory, when you toss a coin, you have a 1/2, 50% chance of getting heads or tails. So that's the theoretical probability that's based on a set of equally likely outcomes and the number of elements in the set. What I'm going to have you practice now is the empirical probability, which means you're counting how often something happens. So the same thing, P stands for probability. It's what you want, what you're looking for over the total. It's the same idea as before, but you're counting how often it happens. So a coin is equally likely to land heads or tails. Such a coin is called a fair coin, because you could have a fake coin, meaning it could be both and people use that to like trick people and never show them. A fair coin has one head, one tails. Empirical probability can be used to determine whether a coin is fair. Well, really, you're just looking at the coin. But here, I want you to take a coin, and if you need a coin, I have some pennies and nickels and dimes. I don't have any quarters, so they're good for tossing. And I want you to actually toss it 20 times, and I want you to count, so you put a tally mark each time you get a heads or each time you get tails, okay, depending on the coin you have. And then we're going to compare what you guys find if you're actually going to have the equal amounts or one more of the other. All right? When you're done, please read example 4, for which the answer is this, which is 42%. Okay?